Welcome to Mastery Lab. From this channel, you will learn not only the knowledge of mathematics, but also the art of problem solving for mathematics competitions. Now enjoy.
Hey guys, this is episode 2 of our new series to teach you guys the basics of pre-algebra and deep dive into challenging math practice problems. Today we're going to look at properties of fractions such as simplest form, fundamental laws of fraction, and exercises that take use of these properties. So let's go! We're going to introduce a new term called simplest form. So what is a simplest form of fractions? Simplest form of fraction happens when the numerator and the denominator are relatively prime to each other. So when two numbers are relatively prime, that means they have no common factors other than 1. Let's look at an example. So say that if I have a fraction 5/8, this fraction is a simplest fraction. And that is because if we look at the numerator, 5 is a prime number, so that equal to 5. 8 is equal to 2 times 2 times 2. So for all the prime factors, they have no common factor. So that makes 5/8 a simplest fraction. Let's look at 15/28. This is also a simplest fraction. And why is that? If we look at the numerator, 15 can be factored into 3 times 5. 28 is 3 times 2 times 2. So for all of these factors, the numerator and the denominator, they have no common factors. So this also makes 15/28 a simplest fraction. Now let's look at an example where the fraction is not a simplest fraction. 34/51. And we're going to use the same method. We're going to factor out 34, and then we're going to factor out 51. So 34 equals to 2 times 17. 51 is equal to 3 times 17. So you probably already see. So 34 and 51, they do have a common factor, and that is 17. Okay. So that makes 34/51 not a simplest fraction. So let's recap what we talked about. Simplest form of fraction happens when the fraction has numerator and denominator that are relatively prime to each other. Two numbers are relatively prime if they have no common factor other than 1. And to find out if two numbers are relatively prime, we do prime factorization on both the numerator and the denominator to determine if the fraction is simplest form. Let's look at our second properties of fractions. The second properties of fraction is the fundamental law of fractions. And the fundamental law of fractions says that if I have a fraction, the value of this fraction does not change if both its numerator and its denominator are multiplied by the same non-zero number. So for instance, if I have a fraction a/b, where b is a non-zero number, and if both the numerator and the denominator are multiplied by another non-zero number c, then the value of this new fraction is the exact same as the original a/b. So let's look at some examples. 2/3 is a fraction, and if we multiply top and bottom both by number 17, then it becomes 34/51. The value of this new fraction is the same as the original 2/3. And if I have another fraction 3/4, and I multiply the top and bottom both by number 5, and that becomes 15/20. Now if you evaluate 15/20, it has the same value as 3/4. Now if we look at this the other way around, that is, if we have a fraction that has common factors in the numerator and denominator, we can cancel these common factors in both numerator and the denominator, and the value of the remaining fraction is exactly the same as the original. Okay? So for example, this time in our example, we're going to start with what we had previously, 34 over 51. 34 is 2 times 17, 51 is 3 times 17. 17 is common in both the numerator and the denominator, so it gets cancelled out. And the resulting 2/3 is the same as 34 over 51. Similarly, if we have 15 over 20, number 5 is common in both numerator and the denominator. That gets cancelled out, and that becomes 3/4. And that also has the same value as 15 over 20. Okay. So this process is called simplifying the fraction. Okay? And the resulting fraction is in a reduced form. Now this is a very important property in fraction and later on plays an important role in fraction operations. So you're strongly encouraged to review this several times. Next, let's walk through several exercise problems together. We will first look at a fraction arithmetic problem, then followed by a few others that will use the properties of fractions. In our first problem, it says, if x is equal to -12 and y is equal to 4, find the value of x times y minus x over y. So in solving this problem, the very first step that we're going to do is we're going to substitute the values of x and y into the expression. Okay? So for x times y, after the substitution, it becomes -12 times 4, followed by a minus sign. Then for x over y, after the substitution, it becomes -12 over 4. Okay? So take a look at this expression here. One thing you'll notice is that it has a lot of operations involve negative numbers, so we need to be on the extra lookout for it. In the next step, we're going to follow the order of operations and we're going to evaluate x times y first. So -12 times 4 will give us a product of -48. Then we're going to convert the fraction into a division. Okay. So the expression becomes -48 minus -12 divided by 4. And the -12 divided by 4, that part comes from the fraction -12 over 4. Now in our third step, moving on, we will be doing the division, also following the order of operation. And -12 divided by 4 will result in a -3. So the expression will simplify into -48 minus -3. So here you'll notice that we are doing operations on all negative numbers. So subtracting a negative number equals to adding a positive number. So minus -3 becomes +3. And that turns the expression into -48 plus 3. And that evaluates to -45. And this is the final answer. Let's move on to our second exercise problems. In our second problem, we're going to find two improper fractions, where both of them are going to equal to a given mixed number. Okay? And that given mixed number is 1 2/3. Now in solving this problem, the very first step we're going to do is we're going to convert the mixed number into an improper fraction. And then from the improper fraction, we're going to find two equivalents of it. So first change 1 2/3 into an improper fraction. Now in that conversion, the denominator of the improper fraction is the same as the denominator of the fraction in the mixed number. So that is 3. And the numerator is going to equal to 1, the whole number, multiplied by 3 plus 2, and that's 5. So now we have our improper fraction. Then we're going to use the fundamental law of fraction to find two equivalents of it. In fundamental law of fraction, it says, given a fraction, if I multiply both the numerator and the denominator by the same non-zero number, the value is the same. So in our case, we're going to multiply the same number to the numerator and the denominator of our improper fraction, which is 5/3. Okay? So in our first case, we're going to pick the value 2. So the numerator and the denominator both multiply by 2, and that becomes 10/6. So 10/6 is a new improper fraction, but it has the same value as the original 5/3. So this is the first equal improper fraction, okay, for our answer. Now for our second one, we're going to pick the value 3 for C. So the numerator becomes 5 times 3 and the denominator becomes 3 times 3. So that's equivalent to 15/9. Okay? So 15/9 also has the same value as the original 5/3. And this is our second equal improper fraction. Okay? So now we have both of them. Let's move on to our third exercise. In our third exercise, we're going to write a fraction that has a relatively big number in both the numerator and the denominator, and we're going to try to find its simplest form. Okay, so we have the fraction 225/540. Okay. Now in solving this problem, the very first step we're going to do is to factorize both the numerator and the denominator. Starting with 225, that equals to 5 times 45. 45 is equal to 5 times 9. So the whole thing is equivalent to 5 times 5 times 9. Now for 540, that equals to 54 times 10. 54 is equal to 6 times 9. And 10 is equal to 5 times 2. So the whole thing can be factored into 6 times 9 times 5 times 2. Okay? So if we substitute in what we had with 255 and 540, the numerator is 5 times 5 times 9, and the denominator is 6 times 9 times 5 times 2. Now you probably see that we have highlighted in red. 5 is a common factor in both the numerator and the denominator. So is 9. That appears in both the numerator and the denominator. So these can be cancelled out, okay, because they appear both in the top and the bottom. And that becomes 5 times 1. Denominator becomes 6 times 1 times 2. So the final answer is 5/12. So far, we have looked at several exercises that uses simplest form property and also the fundamental law of fraction. In this last exercise, we're going to solve for what fraction of 96 is 64. In this problem, we're going to use two different methods to solve for it. And in both methods, you will see that the answer you get are identical. In our first method, the word of means multiply. So the problem can be translated to what fraction multiplied by 96 is 64. And we can convert this phrase into a math equation. Let's see how we can do that. So in our first solution, let's let the unknown fraction be represented by a letter x. Then we can have the equation written as x multiplied by 96 is equal to 64. And to solve for the equation for x equal to 64 divided by 96. And when we have two numbers in the division, it is equivalent as a fraction. So x is equal to 64/96. And this is our fraction. Now let's use another method to solve this problem. Now if we read the words of this problem in the opposite way, okay, so instead of saying what fraction of 96 is 64? How about we read it as 64 is what fraction of 96? Let's see how to solve it. So suppose that if we have a whole pizza, and that pizza is cut into 96 pieces. Okay? And now out of it, you're going to take 64 pieces. Okay? So if we take 64 pieces out of 96, what fraction is your share? Okay. So our solution is, obviously, from this definition of fraction, if we take 64 pieces out of 96, then the share is 64 over 96. So you see that this method results in the same fraction as the previous method. Now 64 over 96 is not our final answer because this fraction is not in its simplest form. And that means we need to find the common factors in both the numerator and the denominator. Okay? So for the numerator, we have 64. Okay? And 64 is equal to 32 multiplied by 2. And the denominator is 96. That equals to 32 times 3. Now you can see that 32 is common to both the numerator and the denominator. And we can cancel that out. So if we cancel that out, x is equal to 2 over 3. And this fraction is in its simplest form. And this is our final answer.